So 2.4, interpret information involving probability. So I'm going to define statistics and data. So statistics is the practice of collecting and analyzing numerical data in large quantities. Okay, statistics help predict the result of future events. So it takes a look at like current and past trends and where something is headed, and then we can predict results for the future events. Okay, an example of this is opinion polls, census data, weather reports, gambling odds, or like sports reports, like team data, player data, etc. Okay, and then data, facts and statistics collected for reference or analysis. Okay, so example 1, using statistics. GM's OnStar service is a wireless communication system because a central call center and an OnStar embedded car allowing drivers to call for help or ask for other services. Okay, the volume of monthly OnStar activity reported by Richard Russell. So here's just like the website that this comes from is as follows. So we're not going to go to that website because I have all the information here. So if you don't know what OnStar is, so here's the data that was collected. So out of a total number of calls of 412,025 calls, 1,000 were because the airbag deployed. Okay, 300 were crash notifications. 11,000 were emergency service calls. 5,400 were Good Samaritan calls, or like orange alerts, someone is in trouble, right? So you can like press the button and be like, hey, someone else is in trouble. And then like maybe you keep driving or you tell them or you stop, whatever, but then they'll send somebody. 325 were stolen vehicles, and it's like a location assist. So maybe your vehicle got stolen, you call and you're like, hi, where's my vehicle? And then like they'll GPS it because there's a GPS on your car for them, right? 41,000 remote unlock calls. Maybe you, like this is old school, but like if you forgot your, like you locked your keys in your car, or if you forgot your keys, or maybe like you went somewhere with like your partner or your sister or your brother, and then they took the keys with them, and then like you're stuck there with no access to your car, right? So remote unlock calls, they can unlock your car from their office. 24,000 requests for roadside assistance. That means like maybe flat tire, ran out of gas, something broke on their car. Okay, and 239,000 requests for route assistance. Okay, so route assistance, this is probably before, like predominantly before the time of like the GPS installed in the car and maybe like cell phones being so adequate, but also route assistance. Maybe you're off like the normal roads and you have no idea where you're going. But anyways, this is a breakdown of the total calls that they got. So let's scroll down to here. So if you were an OnStar operator, what would be the probability of the next call being, okay, a person needing some roadside assistance? So the probability of roadside assistance, I'm just going to call it RA, is the number of roadside assistant calls over the total number of calls. Okay, so if we look up roadside assistance, I can see it's 24,000, and that's out of 412,025. Here. So this is 0.058. So if we multiplied this by 100, we would see that it's 5.8% of phone calls. So there's like, if you were an operator and you were accepting these phone calls and that was your job, there'd be almost a 6% chance that your next call is going to be for roadside assistance. Okay, number 2, a person needing their car unlocked. So this is going to be the probability of car unlocked is going to be the number of calls for car unlocked over the total calls. So if we take a look over here, remote unlock calls, 41,000. And the total calls is going to be the same. It's going to be this 412,025. Okay, if we were to divide those, we get 0.0995. Okay, and if we multiply it by 100, we get 9.95%. So I'm comfortable just putting 10%. So 10% of the calls are because people literally like need in their car, maybe lock themselves out. All right, now what type of call has the highest probability? And then we're going to state the probability. So if we think about the highest probability, we're looking for the biggest frequency. Because no matter what, the probability of whatever is the highest probability is going to be some number over 412. Okay? This number 412,025 is not changing for the denominator. That's still going to be the total number of calls. We're looking for the biggest number for the numerator. So scrolling up here, 1,300, 11,000, 5,400. I think the remote, nope, I'm lying, 239,000 for root assistance. So it is definitely root assistance. So root assistance, and it's 239,000. Calls. Okay, if you divide these, we get 0.58, which gives us 58% of the calls are for root assistance. Okay. Now, lowest probability. What are we going to look for? We're going to look for the smallest frequency. Okay, so we're looking for the smallest number. So if we go back up here, 300 is small, 325, nope, 300 is smaller. Okay, crash notifications. So it is going to be, let's go, probability of crash. I'm going to write it out so I don't have to write it twice. Notifications. And we get 300 over, again, the same denominator, 412,025. And if we divide those, we get 0.0007 or 0.07%. That's very, very small. Example 2, all students at a high school were interviewed. So this is like an opinion poll about whether they like basketball, football, both, or neither. So state the probability of each outcome as a fraction and then as a decimal. So for the fraction, what we want to do is we want to add up, because our denominator will be the total number of students, total number of responses. Okay, so we're going to go 190 plus 340, right? All of these numbers here, plus, I believe it's 565, plus 100. Okay, and then what do we get as a total number of students that are in that high school? Okay, so 1195. Okay, so how many students like basketball? Well, 190 out of 1195. How many students like football? And this is like football only. 340 students like football out of 1195. How many like both basketball and football? 565 out of 1195. And neither is going to be 100 out of 1195. So if I did 190 divided by 1195, I get 0.159. I'm going to do 3 decimals. 0.159. Okay, 340 divided by 1195, I get 0.285. Okay, 565 divided by 1195, I get 0.473. Okay, and the last one, 100 divided by 1195, 0.08. Oh, it's a 0.084. Okay, what we can do to ensure that we have these calculations correct is we can actually add up this column here. So we're going to go down that column and we are going to add 0.159 plus 0.285 plus 0.473 plus 0.084. Okay, and we get 1.001. Okay, so this here means 100%. This can be due to rounding error, because technically we have to have everything add up to exactly 100%, or like 100% of the people. But if it's 0.001 off, it's just due to rounding error. Because if we kept it as a fraction, it would be exact. Okay, so now let's interpret. All right, what is the probability that a student likes basketball but not football? Okay, so that means that we're taking a look at basketball only, not football, not both. Okay, because remember, that's basketball and football. Both is basketball and football, so it's just specifically basketball. So the probability of liking basketball, let's call it B, is, okay, it's 190 over 1195. Okay, 2. What's the probability that a student likes either basketball or football, but not both? So this is going to be probability of basketball or football, not both. Let's write it like that. So what we're going to do is we're going to find the probability that the student likes basketball and the probability that the student likes football. And the reason why this not both is in there is because if a student falls into the both category, then they do like basketball. So we have to specifically say, like, we're not talking about that group. We're just talking about just basketball or just football, one or the other, right? So this is like one or the other, not both. So probability that you like basketball is 190 over 1195. Then we're going to add the probability that you like football, which is here, 340 over 1195. And when we're dealing with fractions, all we do is add the numerators. Okay, so we get 530 over 1195. Now, what's the probability that the person likes basketball or football or both? Okay, well, this time what we're going to do is we're going to find the probability of the person liking basketball, the probability of the person liking football, and the probability of the person liking both. So the probability that the person likes basketball is, again, 190 over 1195. Okay, we just figured that out right here. Then the probability that the person likes football is the same as before, 340 over 1195. This time, we are going to consider the probability that an individual likes both basketball and football, which is this one right here. So 565 over 1195. So again, with the fractions, what we want to do is we want to add all the numerators. Okay, so the total of individuals who like basketball, football, or both is 1095 over 1195. Okay, example 3, actual statistics from the NBA standings for some, so that's just some of the Eastern Conference teams are written here. So based on these statistics, predict their probability of winning for each of the following teams. Okay, so for example, we're going to do the Raptors first. So Raptors number 1 right here. Okay, so what we're going to be looking for is the probability that the Raptors win, which is the number of Raptors wins over the total games that the Raptors play. Okay, so they've won 41 times. And if we take 41 plus 17, which is the number of games that they've won and the number of games that they've lost, and we add those together, we actually get 58. So the Raptors have won 58 games. So if you think about 41 over 58, that's 0.71 or 71%. So the probability of the Raptors winning is 71%. Okay, so now the Cavaliers. So track down the Cavaliers. We have it here. So the probability that the Cavs win is going to be, so their winning rate is 35. And the total number of games that they've played is 35 plus 24. They've won 35 of them and they've lost 24 of them. So 35 out of 59. So they have a 59% win rate. Okay, so the probability the Bucks win, again, we add up their wins and their losses, so the total number of games is 59. And the Bucks have won 33 out of 59 games, so that's 56%. And then again, the Pistons, the probability of the Pistons winning is 28 over the total. So they've played 28 plus 31 games. So 28 over the total number of games, which is 59. Okay, again, 49%. So taking a look at these, why are these percentages not completely accurate? And what other information do you have to take into account? Okay, so when we're talking about professional sports, we have to take into account injuries, right? Did everybody play? Okay, was anybody like sat? It's called sat. Or like not able to play that game, right? So either not able to travel or they were in trouble. Maybe like they swore at a conference or something, right? So that if they had to sit that game, not able to play, right? During COVID, I think some people were waiting to get cleared, etc. Okay. Another thing that we have to take into account is, are they on the road versus home? Okay, home court, because they have like all their fans and all the energy in the stadium on their side when they're at home, but when they're on the road, they have nobody. And then if you actually take a look, like the Raptors have played less games. So number of games played you have to kind of consider. Okay, you can also consider who they played and who they still have left to play. Okay.